we've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler 22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler 22b is that it's about 15% closer to its star than we are to the Sun. If Kepler 22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler 22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler 22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler 22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler 22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler 22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler 22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler 22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler 22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler 22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler 22b. That would be awkward if it turns out to be a gas planet, or something like that.
It's the year 2600, and the New Frontiers program has finally begun. You've got the list of planets to plan dwellings for, and the first one is Venus. The Earth's evil twin sister meets you with a refreshing 800 degrees Fahrenheit and a beautiful sulfuric acid rainstorm. First of all, the heat means living on the surface here is next to impossible, so you immediately put the prospective house several dozen feet underground. The walls, floor, and ceiling must be made of some heat-resistant and durable material, so you make them out of hafnium carbide. Discovered way back in 2016, it withstands temperatures of over 7,000 degrees. Next, you install the air cooling and purification system. It captures the toxic air from the Venusian atmosphere and pulls it through a complex network of filters, delivering breathable air to the dwelling. As an added benefit, the temperature of this air can be easily turned up thanks to what's going on outside. You can create a separate room below the main space and dub it the generator room. The device there will use the almost infinite geothermal energy of the planet to provide the house with electricity. You think for a moment and add a geothermal bathroom as well. There's no water on Venus, but it can be extracted and separated from its acidic clouds. The piping system would include a heating unit for hot water and a cooling unit with liquid nitrogen for cold water. Another separate space is the garden. Since no plants can survive on the surface, you create a spacious hall with bright lights on the ceiling and a sprinkler system throughout the area. You have large patches of soil for vegetables, several acres for fruit plants, and a big patch in the center for a couple of long-living trees like oaks. They'll provide additional oxygen for the whole building. The garden is encased in a shell of hafnium carbide as well, so that the plants don't wilt in the excess heat of the Venusian soil. You check if everything's accounted for and go to your next stop. Saturn. It's a gas planet, but there's a thin yet stable layer that can be called the sweet spot. Its temperature is just right for humans to feel fine. You create a hover platform to build your house on. There's just no solid ground on Saturn at all. The platform's equipped with wind-powered turbines. The winds on the gas giant reach incredible speeds, so it will need to counteract them, at the same time feeding from the hurricanes. The pressure and temperature are just about right in this place, so your main concern is the wind again. You make the dwelling low and looking almost like a frisbee for better aerodynamics. The walls and roof are made from a single slab of sturdy metal, so that powerful gusts can't tear the roof away. You also make them several feet thick and add some windows with space-grade glass panes that won't break. Water can be extracted from another layer using a series of similar platforms with built-in pipes. Electricity and heat are no problem either, thanks to the powerful winds. The only problem here is food, but it can be imported from other inhabited planets at first, along with the fertile soil for the garden. You create a space for it on another hover platform for the future. Satisfied with your results, you head to the next destination on your list, Europa. This moon of Jupiter's is covered in a miles-thick crust of ice full of canyons and crevices. But deep below, there's a whole ocean of salt water bigger than all the oceans on old Earth taken together. You take it into account and go for an underground dwelling again. The temperature is freezing, but the closer you are to the hot planetary core, the warmer it is. You place the dwelling as deep as you can to safely extract water from the underground ocean. The walls and ceiling are padded with insulation, and in the cellar, there's a home water purification system that turns salty water into the potable kind. Since there's no atmosphere to speak of, the breathable air is extracted from the ice. As it melts, the water vapor is collected and filtered, then enriched with other necessary substances and delivered to the dwelling. As for food, you go for an unusual solution: edible marine plants and fish. You create a separate tank to cultivate algae right in the ocean, and different kinds of fish can be imported from old Earth and other inhabited planets to breed on Europa. Next stop? Pluto. The tiny dwarf planet, just 1/6 of old Earth in width, has a great potential for terraforming. So you immediately create a big dome for your dwelling. The sun shines much weaker here than in any other place in the solar system, so you make sunlight-enhancing panels all across the dome. They'll allow the surface underneath to receive more light and warmth, bringing the area to a comfortable temperature. The ice on Pluto consists of frozen water, just like on Earth, so you build a station for melting it and collecting the resulting liquid into large tanks for later use. There's also a possible liquid ocean deep under the surface, so you add a deep drilling platform, but put a question mark on it. You don't know if it's going to be useful yet. With the area warmed up and well lit, you make a pretty ordinary dwelling like ones we're used to on old Earth and terraformed Mars. A couple of stories, carbon or titanium alloyed walls and ceiling for durability, and a fortified cellar. Still, you also add emergency insulation padding that will only trigger if something happens to the lighting dome. If it's breached, the temperature will quickly drop to below freezing. There's also very little atmosphere on Pluto, so breathable air will have to be generated from the ice again. This time, you combine the water collecting system with the air generating facility. While one produces potable water, the other will collect vapor and enhance it with all the necessary elements. You even go as far as to create a weather-controlling device. It will heat up or cool down different layers of the produced air and mix them together to create winds and rain clouds just like on old Earth. This will allow crops to grow in a more natural environment, and Pluto might even become a green planet one day. Right above, in the dark blue sky, Pluto's biggest moon, Charon, is hanging. It's half the dwarf planet in size, which makes it a spectacular view. Its climate is almost identical to that of Pluto's. In a fit of inspiration, you create a vacation home for Plutonians. Here, under a similar dome, they'll be able to explore another little world and look at their dwarf planet from the other side. Which is always the same side, by the way, like the Earth's moon, which reminds you of the next destination. Zarmina, previously known as Gliese 581g, is 41 light-years away, the longest trip so far. The planet's tidally locked to its sun, which means there's perpetual day on its one side and eternal night on the other. It's not only about light, but heat as well. The day side is much hotter, and the night side is partially covered in ice. Unless we terraform the planet, the most comfortable area to inhabit is right between the two sides, called the Terminator Zone. It's neither too hot nor too cold here, and there's an eternal twilight. The sun is always just above the horizon. The good news is that the atmosphere on Zarmina, although volatile, is rather close to the old Earth's, but you still cover the selected area with a protective dome just in case. Human dwellings here don't have to be specially protected from the elements, and there's liquid water too. You build a pretty generic house, much like the one on Pluto, but then add a few crucial details. First, the weather controlling device. Despite the old Earth-like atmosphere, dwellers will need a stable change of weather to grow crops. Then you cover the dome with moving plates. Living in a constant dust might be pretty depressing, so the plates will move in 12-hour patterns. During the daytime, they will turn to enhance the sunlight, while at night, they'll deflect it back, making the sky dark. After that, you travel to both edges of the Terminator Zone and install geothermal plants. On the hot side, the plant will generate energy for all the settlers' needs and take hot water to use in households. On the cold side, the system will make cold water from the ice. The night side can also be used as a giant refrigerator. Dwellers could store things they need frozen here. To make it easier to access, you stretch the dome from edge to edge and create some simple storage facilities where the night begins in earnest. The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter. High tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color, very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too.